Alright, so in this video, I'm gonna be explaining another important paper with the title Graph Ordering Attention Networks. This paper in 2022. Graph neural networks have been successfully used in many problems involving graph-structured data, achieving state-of-the-art performance. GNNs typically employ a message passing scheme in which every node aggregates information from its neighbors using a permutation invariant aggregation function. Standard well-examined choices such as mean or sum aggregation functions have limited capabilities as they are not able to capture interactions among neighbors. So we formalize these interactions using an information theoretic framework that notably includes synergistic information. Driven by this definition, we introduce graph ordering attention layer, a novel GNN component that captures interactions between nodes in a neighborhood. This is achieved by learning local node orderings via an attention mechanism and processing the ordered representations using a recurrent neural network aggregator. This design allows us to make use of a permutation-sensitive aggregator while maintaining the permutation equivariance of the proposed GOAT layer. The GOAT model demonstrates this increased performance in modeling graph metrics that capture complex information such as the betweenness, centrality, and the effective size of a node. In practical use cases, its superior modeling capability is confirmed. So we always in graph neural network do aggregation and use this aggregation using the combine to have this representation of each node. But there are common aggregators, for example, relational reasoning, injectivity, and they have pros and cons. But several authors have proposed the use of permutation-sensitive aggregators to tackle limitations of permutation-invariant aggregators. So, an information theory perspective, it's about partial information decomposition. The domain of information theory provides a well-established framework for measuring neighborhood influence. A few graph representation learning results capitalize on information theoretical tools, either assuming probability distribution over feature vectors or over the structural characteristics. So you know about permutation, mutual information between two random variables. This is an illustration of partial information decomposition. The unique information in the neighbors V1 and V sub 2, their redundant information and the additional synergistic information is like this. You know, in cognitive neuroscience, you have three kinds of information. Either it is synergistic, either it is unique, or redundant. So I think this is their motivation to produce such a decomposition. And then we have this graph ordering attention layer, that the ordering part transforms the unordered multiset of neighbor hidden state vectors, each of dimension d, into an ordered sequence using an attention mechanism. So you can have these attention scores, but we sort the coefficient in the decreasing order of the magnitude. So once we have calculated the attention, we sort them, and now here we construct a sorted sequence of neighborhood hidden states. And the second part is the sequence modeling part. Takes the ordered sequence of nodes produced by that and processes them using an RNN, because it's a sequence, using LSTM. Now here we are using LSTM to process this sequence, because using attention we created the weights and then we ordered that, they sorted that, and then now we have a sequence, then we have a representation of a sequence. Then they worked on the multi-headed version of that to remove the noise, or at least reduce the noise. And then they compare, for example, graph convolutional networks and graph sage with the GOAT, that you see improvement for classification accuracy. Or they also did for node classification of these Cora datasets, Sightseer. They are very good datasets. Physics is very simple. Its state of the art is 96, but for example, Cora is for multi-layer perceptron is just 43%, but for graph convolution is 81. So for 3% improvement for GOAT is 84%. Also, graph attention, because it's using graph attention, so it's just 1% improvement. And this is how they resolve the ties.